Alright, today we're going to talk about distance on a coordinate plane. We are going to look at examples in all four quadrants. So we have our origin here, where everything starts. Of all four quadrants, I'm going to make up a point at 4, 2. I'm going to label it just so that you can follow along. And then I'll also make up a point at 4, 5. 1, 2, 3, 4, 5. So starting in the first quadrant where everything is positive, here I have 2 points. I want to know how far apart are those 2 points. So when you have values that are in the same quadrant, it's just as simple as counting the spaces between them. 4, 2 to 4, 3 to 4, 4 to 4, 5. That would be 3 spaces. Especially easy to count if we had our grids going all the way across. But totally doable even if we don't. So that is 3 units apart. One way to figure that out is to say, my x values are staying the same. They're staying at 4. My y values are changing. What's the difference between 5 and 2? 5 minus 2 is 3. These are 3 units apart. Let's try another example in a different quadrant. My personal favorite quadrant is quadrant 3 down here. Really, it's my personal favorite because when you graph the signs in this quadrant, x values are negative, y values are negative, and I think it looks like a little face. All the quadrants have different ordered pairs with different signs, but I'm going to go here in the third quadrant. I'm going to start with this point here. Remember to label your point. You always start with your x value, so this is going to be -1, and then you go to your y value, -2. And I want to know what is the distance from this point to this point here. Starting with my x value, -4, my y value, -2. Now this is slightly different than our first example, because now we are moving horizontally instead of vertically. Same idea though. If I look at these two ordered pairs, I'm seeing -4, -2, and -1, -2. Notice how in each example, one of my coordinates, in this example my x coordinate, in this example my y coordinate, they're staying the same. So I'm really going to focus on the coordinates that are changing. What's the difference between -4 and -1? Now, if you don't want to subtract them, if you're not comfortable doing -4 minus -1, you can plot them on a graph and just count the spaces. 1, 2, 3 spaces between those points. This one also has an answer of 3 units. But what happens if I have one point in one quadrant and another point in another quadrant? Alright, so before I graph 2 points, I want to point out my axes. My y-axis, you can see I'm counting by an interval of 1, 2, 3, 4. It's going +1 every time. On my x-axis, though, I'm actually not. I'm counting by 2's here. Each line represents 2 spaces. So counting the number of boxes is not always going to get you your correct answer. You also need to keep an eye out on what the interval on each axis is. Because you'd hate to say, oh, the distance between these 2 points is 2 units. The distance between 6 and 2 is not 2. It's 6 minus 2, 1, 2, 3. That's 4 spaces, even though it just looks like 2 spaces here. So you have to always pay attention to your intervals on each axis. Alright, I'm going to use this point right here, which is 2, 1. And then I'm going to say, what's the difference? How far away is this point to -4? The difference between this problem right here and one that we did before was that the one that I did before never crossed an axis. This one, I'm looking for the distance of this blue line right here, which does go across my x-axis. It's not the same kind of problem because I cannot just say what's the difference between 1 and -4. I'm going to think about this in terms of absolute value. This is my y equals 0 point. So starting right here on my x-axis, this is one space away from the x-axis. This right here is 1, 2, 3, 4 spaces away. So what I can do is I can take the total spaces, 1 plus 4, and say, oh, these points are 5 units apart. Now you can find the difference, but we haven't done integer subtraction, so we are not ready yet to do this problem, which is why we're going to use our absolute values to help us solve problems where you are finding the distance across an axis. Let's look at one more example. What will you do if I give you a problem that does not have a picture of a coordinate plane on it? So what's the distance between these 2 points? Oh, okay. Suddenly I don't have a picture in my head. If you want to draw one, you can. But we could solve this without it. I see the 3 and the 3 stay the same, so I'm looking at a distance in the x direction. I'm looking between -6 and +10. Alright, let's take the absolute value of -6 and the absolute value of 10. 10 is 0 spaces away, or 10 is 10 spaces away from 0. -6 is 6 spaces away from 0. 6 spaces on the left versus 10 spaces on the right. That's why this one has a negative sign and this one is positive. 6, not 0. So this is 6 spaces and 10 spaces. So add them together. 6 plus 10 means these are 16 spaces or 16 units apart. If this is not really working for you, you are a visual person, go ahead and draw yourself a graph. You can plot these points, and then it is easier for me to see, the distance between this point and my y-axis. Don't be fooled, don't think it's 5. Remember, you have to check your intervals. This is the point 10, so to get from 0 to 10, you have to go 10 spaces. And right here, to get from 0 to -6, don't be fooled, look at your interval, you have to go 2, 4, 6 spaces. The distance from here to here is going to be 6 spaces and another 10 spaces, add them together, 16. So whether you can do it just like this, or you want to draw yourself a graph, both ways will work and help you find distance across an axis.